Hello, Magic Unicorns. Today we're going to be talking about the diameter chord theorem. Now, if you remember, a diameter is a line that goes straight through the middle of a circle, and a chord is any line that has its endpoints on the ends of the circle. Now, what we know is this. In a circle, a diameter that is perpendicular to a chord bisects the chord. And what does bisects mean? That's right, cuts in half. Cuts in half. So, if I have a diameter like I have right here, and it's at a 90-degree angle, it's perpendicular to a chord, then what I know is that it bisects this chord. And bisects means it cuts it in half, meaning I have two congruent pieces. So if this middle part, let's say, is point E, I would know AE is congruent to EB. And I know you're saying I get it, but just to give you an example, if AE was 10, I would know EB was 10. And I know you're saying I get it, but here's another example. If I knew that AB was equal to 30, this whole thing was equal to 30, and I asked, hey, what is AE? Well, since I cuts the whole thing in half, I know that this would be 15 and this would be 15 because 30 divided by 2 is equal to 15. So each one of these would be 15. Boom. Okay, now let's get into it. In the diagram, this is a real Regis problem, the diameter AB is perpendicular to CD. So these are perpendicular, meaning there's some 90-degree angles right there. What we know is CD is 14. What I want to know is the length of CE. I want to find out what CE is equal to. Well, let's just take a look at this. CE is where? CE is this guy right here. Alright? Well, if I know the whole thing, CD is 14, and I know that both of these are congruent, I would just say that 14 is equal to CD. And since I know that CE is half of it, I would just say CE is equal to this cut in 2, which is 7. Boom, this is 7, this is 7, easy peasy. Let's go on to our next challenge problem. Now, here's about to get real, so I hope you're paying attention. In the accompanied diagram of circle O, this is circle O because there's an O here, diameter AB is perpendicular to chord CD. So I know these are perpendicular, 90-degree angles everywhere, right? If we know AE, this part right here is 9, and EB is 4, how can I find out what ED is, which is this guy? Now, this is where you have to pull back your memory. Now, if you remember, we learned the chord theorem. Remember the chord theorem? The chord theorem says that if I have two chords, right, like I have here, I have two chords, right, then I know the first segment times the second segment is going to be equal to this segment, which I don't know, times this segment, which I also don't know. Now, if I'm calling this segment X, I could also call this one X because these two are equal, because it was bisected. So using the chord theorem, I could say that 9 times 4 is equal to X times X. Now I hope you understand why I'm using X's. I don't know what C is, I don't know what ED is, but I know that they're equal, so I could say that they're both equal to X. So that gives me 36 is equal to X times X is 2X. No, it is X squared. I take the square root of both sides to find my answer, and so I get X is equal to 6. Absolutely. So let's take a look at this guy. We can use the same kind of technique, so let's take a look. We know in the accompanying diagram of circle O, diameter AB is perpendicular to chord CD. What that tells us, remember, if I know that this chord is perpendicular, then I know that CE is equal to ED. Now what we know is CD is equal to 8. So this line right here, this chord, is equal to 8. And we know EB is equal to 2. We want to find the length of the whole diameter. Alright, easy. We could definitely do that. Now check it out. this is what we know. We know, once again, the chord theorem, which states that this part times this part is equal to this part times this part. And since I don't know this whole part right here, let's put a little x over here. Now, once again, going back to some knowledge, if I know that CD is equal to 8, what's this equal to? Yeah, 4, remember? Because each part is half. So if I wanted to find out what x was, I just use the chord theorem, which just says that this segment times this segment is going to be equal to this segment times this segment. So let's try it. So we know 4 times 4 from the chord theorem is going to equal 2, which is right here, times x. So this gives me 16 equals 2x, and that gives me x equals 8. And you might think that's the answer, but this says what's the diameter? That's the whole thing across. So if I know x is equal to 8, and EB, this part right here, is equal to 2, I know 2 plus 8 equals 10. So my diameter is equal to 10, once again, because I know this part is 8 and this part's 2. Alright, kids, remember, go home, tell your parents you love them, never play your music too loud, and always, always hold your little brother or sister's hand when you cross the street.